Alright, in this video we're going to be looking at a set of reflections, and we're going to decide what was the reflection that was done here. Alright, so let's just take a look at a few of them. Okay, when I look at this one here, I see it looks like x to x prime, w to w prime, z to z prime. It looks like everything was flipped kind of reflected along this diagonal line that runs through here. And we only have so many options. Right, this clearly isn't a perfectly vertical flip, a perfectly horizontal flip, or reflection. But just to be sure, if you look here, see how the line y equals x? All right, you see how w and w prime are both kind of half of a diagonal away, and the key here is that any point should be the same distance. It should be the same distance from the line of reflection to that point as it is from the line of reflection to its image under that reflection. So if you look here, x is 1, 2, 3 diagonals away, and then x prime is 1, 2, 3 diagonals away. When I say diagonals like that, I mean just, you know, square root of 2 times 3, 2 times square root, or 3 times square root of 2. All right, if you look at z prime, 1 diagonal, and z up to the line is 1 diagonal. So as long as every point is the same distance to the line of reflection as its image, then you've got the right line. You just kind of have to eyeball it, and I think in this case it's pretty clear. Okay. Let's look next door. This one, if you look here, it was below the axis. It looks like I got flipped up above the axis. So it's been reflected across the line, or across the x axis. Right. And if you look here, v prime, 1, 2, 3, 4, v, 1, 2, 3, 4, y, 1, 2, 3, y prime, 1, 2, 3, and so on. So not too terribly complicated. All right, this one is just a little bit tricky. Look down here. You'll notice there's this kind of symmetry that just goes through this line right here, right, in the whole figure and its image. If you look here, r is 2 spaces away from the line of reflection, and r prime is 2 spaces away from the line of reflection. P is 3 spaces from the line of reflection. P prime, 3 spaces from the line of reflection. And Q prime and S prime are both on the line of reflection. So this is kind of like a sort of offset diamond shape, and it's been reflected across the line. X equals -2. And you'll notice the line x equals -2 is made up of all the points that have an x coordinate of -2. All right, speeding it up a little bit here. This, well, if this were across an axis, it would have ended up here or over here. If it were across some sort of vertical or horizontal line, then it would have ended up straight up or straight over, but it ended up on this diagonal. So it clearly has to be a diagonal line right through here. Y equals x. Looking at this one down here, again, it started out down here. It kind of reflected over a diagonal line. And since we only have so many options here for diagonal lines, in fact, we only have 2, it is y equals x. Over here, you can see that it was a horizontal reflection, and it's across this line right here. And this is the line x equals 1. Let's see what else we got. Here, this is a new thing. Alright, this is again a diagonal reflection, but this time it's over a diagonal line going in the other direction. This is y equals negative x. So at every point on this line, the x and y coordinates are each other's opposite. So for example, 1, negative 1, or negative 2, positive 2. Okay? Here, all right, if you look, I've got k, k prime, j, j prime. They're clustered around this diagonal line right here, which is y equals x. Here we have, again, C, C prime, B, all clustered around this diagonal line, which is y equals negative x. Let's see here. You can see that this is clearly a horizontal reflection, and you just got to figure out what line is the same distance from every point and its image. It goes right down to the center here, n prime, n, each 1 unit away. M is 3 units away. M prime is 3 units away. And this is the line. Oh, well, this is the y-axis. Oops. I have a timer going off for pizza here. So I'll finish these last two up pretty quick. Here, vertical. And here's the line, which is the x-axis. And then next door here, you can see this is again a diagonal sort of reflection. And we'll just go through it like this, and this is y equals x. Now, the one thing is, if you don't quite see it right away, it's okay. The thing you want to do is just kind of sketch in your line. Maybe don't use pen like I did. Use pencil, and ask yourself, is every point and its image the same distance from the line? So if I were to say, I don't know, say on this one I had thought it was the line y equals x for some reason, right? Then I would notice that t was 1, 2.5 diagonals, but t prime was 1, it was like way off, right? Actually, it would work. It wouldn't be right. Well, you look at R. R would be right on the line, so 0 spaces from the line of reflection, and R prime would be 1, 2, 3 diagonals away. So every point needs to be the same distance to the line as its image is from the line. And if that fails, you've got the wrong line, and try something different. Okay? Good luck.